So now we will be discussing about data types. Data types in programming are as fundamental as variables. Data types are fundamental concepts in programming as they define the kind of data that can be stored and manipulated within a program. So understanding data types is very necessary for us to know what to do and how to do it, right? So data types are fundamental concepts in programming, and they define what kind of data can be stored and manipulated within a program. Understanding data types is crucial because they determine how data is interpreted by the computer, how much memory is be allocated, what kind of operations can be performed on the data. Definition of data types is different for different data types, right? Data type is a classification that specifies the type of data a variable can hold. It defines the possible values for that type, the operations that can be performed on it, and the way the values are stored in the memory, right? So there are some categories of data. Primitive data types, and it can be categorized broadly into two categories, into primitive or fundamental data types, composite or complex data types, right? So primitive data types are the most basic provided data types by a programming language. They are the building blocks for data manipulation and are typically defined by the language, right? So we have int for integer. It represents whole numbers without a fractional component, right? And int x equals to 42. Typically it's an example, int x equals to 42, and memory usage typically 2 to 4 bytes depending on the language and platform, right? And so there are operations, arithmetic operations, addition, subtraction, multiplication, bitwise operations, comparison operations, right? Then you have floating data types, right? Float point, float double represents numbers within a fractional component using decimal points. Floating point numbers are used when more precision is needed, like pi, float pi equals to 3.4, double distance equals to whatever 1, 2, 3, 4 point something, right? The memory usage is float typically uses 4 bytes and double uses 8 bytes, right? And operations are mathematical operation, functional operations like trigonometric functions and comparisons. Then we have char character data types, right? which represents single characters, like a single character or digit or a letter A, B, C, anything, right? And the memory usage is typically 1 byte in ASCII, 2 bytes in Unicode, depending on the language. So yeah, that's about it. Operations, you can use concatenation when combined with strings, comparison, checking if one character is greater than another, and arithmetic operations in some context, right? Finding the ASI value. Then you have the Boolean data type. It represents a value that can all be true or false, right? That can only be true or false. Booleans are often used in conditional statements and control flow. Bool is raining is equals to true, right? If it's raining, right, bool. Right, so that is an example of a Boolean expression. Memory use is typically 1 byte, also in some systems only 1 byte is actually used, only 1 bit is actually used, but the usage can go to 1 byte as well. Operations, logical operations and or not, comparisons and control flow statements, operations like conditional and loops. Void, what is the next point? So it represents the absence of a type. It's primarily used to indicate that a function does not return a value, which syntax can differ, but it's basically written like this, right? Writing my function. Memory usage is not applicable as void means no type, so it means like that. Operations, typically it's used in function declarations or pointers in certain languages like C or C++, right? Then we have composite complex data types. Composite data types are built from primitive data types and allow for the creation of more complex data structures. First and foremost is array, right? A collection of elements of the same type stored in a contiguous block of memory. Each element is indexed by a number or by an index. Example, int numbers, right? Memory usage depends on the number of elements and the type of each element. For instance, an array of 10 integers in a language where int is 4 bytes would take about 40 bytes, right? Operations: indexing, accessing elements by their position, iteration, sorting, searching, etc. Then you have strings. So string is a sequence of characteristics created as a single data type, right? Strings are often used to handle text like hello world. String is a greeting, the basic example. And memory usage, it depends on the length of the string and the character encoding, right? Unicode, ASCII, operations, concatenation, substring, extraction, length, calculation, comparison, and searching. Then you have something called struct or structures, right? So description, a composite data type that groups variables of different types together under a single name. Structures are used to represent more complex data. Struct point, int x, int y, right? So the memory usage, the sum of the memory required for each number or for each member, often with additional padding for alignment. Operations include accessing and modifying individual fields, passing structures to functions, right? Then we have unions. Unions is similar to structure, but all members share the same memory location, right? This means only one member can hold a value at any given time. So, example would be like this. Union data and I float half and so on. Syntax may vary, but this was some basic example, right? The memory usage, the size of the largest member as all members share the same memory space. Operations, accessing and modifying the most active member. Care must be taken to only the value of the most recently assigned member, right? Then you have class or objects. In object-oriented programming, so it's a blueprint for creating objects, instances. A class encapsulates data, attributes, and functions, methods that operate on the data, right? So everything is a class in object-oriented programming. So it depends on the memory usage depends on the number of attributes and their types, along with additional overhead for object management. Right, operations include instantiation, creating objects, methods, invocation, inheritance, polymorphism, encapsulation. Right. Then we have something called pointers. So pointer is actually a variable that shows the memory address of another variable. Pointers are used for dynamic memory allocation, array manipulation, and implementing data structures like linked list. And examples are but are not limited to int, ptr, and equals to variable. So this is actually something different, right? And the memory usage is typically 4 or 8 bytes depending on whether the system is 32-bit or 64-bit. Operations are dereferencing, accessing the value at the stored address, pointer arithmetic, dynamic memory allocation, right? Then you have something called enums, enumerations. Enumerations. A user-defined data type consisting of a set of named integer constants. Enums are used to assign symbolic names to integer or constants, improving code readability. Right. So anything can be an enum. Let's say I create an enum. Direction. Right. 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 So this is an example of enums. Memory usage, typically the size of an integer, as each enum value is largely represented usually represented by an integer. So operations, comparison, switch case statements, and bitwise statements, abstract data types, edits, right? So you have a list. List is basically an ordered collection of elements where each element is accessible by its position in the list. List can be implemented using arrays or linked list, right? Operations include insertion, deletion, transversal searching, and sorting. Then we have something called a stack. Right. So a collection of elements with a last and first out access. Elements are added and removed from the same end, the top of the stack. Operations include push, add an element, pop, remove the top element, peek, view the top element, is empty and is full. Then you have something queue. Queue is a collection of elements with first and first out access. Right? Elements are added at the rear and removed from the top, front. Operations include enqueue, add an element, dequeue, remove the first element, peek, view the first element, is empty and is full. Then you have something called linked list. A linear data structure where each element node contains a value and a reference or link into the next node in the sequence. Linked list can be singly linked, doubly linked, or circular. Insertion, deletion, transversal, searching, and reversal. Then you have something called trees. A hierarchical data structure where each element node has a value and reference to other nodes' children. Trees are used to represent hierarchical data structure like file systems. Operations include insertion, deletion, transversal, in-order, pre-order, post-order, searching, and balancing. Then you have something called graphs. A collection of nodes, vertices, edges connecting them. Graphs are used to represent networks such as social networks, road maps, communication networks. Transversal operations are like transversal, BFS, DFS, shortest path finding, cycle deletion, cycle detection, and connectivity checking. So there are some importance of choosing the right data type. First and foremost is the efficiency, right? The choice of data type directly affects the performance of a program. For example, using a smaller data type like int instead of long can save memory and improve cache performance. Data types like float and double are chosen based on the required precision of the calculations. For example, financial applications might require double to avoid rounding errors. Right? Memory usage, choosing the appropriate data type. Choosing the appropriate data type helps organize memory usage, especially in memory-constrained environments like embedded systems. Type safety, strongly typed languages enforce the correct usage of data types, preventing errors that might arise from operations on any incompatible type, right? There are type systems, static and dynamic typing, right? So we have type systems. That is static. Static typing, the data type of a variable is determined as compile time. So languages like C++, Java, Rust use static typing. This can catch type errors early in development but requires more upfront type definitions. Right? Then use something like dynamic typing. The data type is determined at runtime. Languages like Python, JavaScript, Ruby uses dynamic typing. This offers flexibility but can lead to runtime errors if you do not handle it carefully. So always try to handle it carefully, right? Then you have something called strong and weak typing. Strong languages through strong typing enforce strict rules about how types can be converted or used together. Errors are most likely to be caught at compile time or runtime. And some examples include Java, Python, Haskell, right? Then we have weak data type. right? Weekly typing languages allow more flexibility in how types are used or converted, which can lead to unexpected results. Some examples are JavaScript, PHP, right? Then you have explicit conversion, also known as casting. This is when the programmer manually converts a value from one type to another. So this is done actually to when implicit conversion might lead to loss of data or when precision is important. So implicit conversion is typically done using a cast operator in languages like C, C++, float, or methods in languages like Java, and math.round value, right? Converting a double to an int to remove the decimal part, right? So this basically there are some risks while casting can be useful. It can also lead to data loss or unexpected behavior if not done carefully. For instance, casting a floating point number to an integer truncates the decimal part, and casting a larger data type to a smaller one can result in overflow, right? So then we have memory and data types. Memory allocation, the amount of memory allocated for the amount of memory allocated for a variable depends on its data type. Primitive data types generally have a fixed size, whereas composite data types like arrays or classes might vary depending on the number and types of their elements or members. Then there is something called alignment and padding. So alignment in some languages, memory alignment is necessary for efficient access. This actually means that data might be stored in a specific memory location, right? So aligned addresses, right? Padding might be added to ensure this alignment, leading to potentially more memory being used than the exact size of data. Endiness, right? The order in which bytes are stored in memory. Big endian versus little endian can affect how data is interpreted, particularly when working with different data types or transferring data between different systems. Right. So these are some important data type is actually the most fundamental part of programming, right? Right. Then you have data types in different programming languages, right? Procedural programming. You have procedural programming in languages like C. Data types are used to define variables, functions, and data structures. The emphasis is on manipulating these data types through procedures or functions. Then you have OOPS concept, object-oriented programming. Right, it's very important. OOPS. In Group languages like Java, C++, data types are often encapsulated within classes or objects. So classes define new data types by bundling data attributes and methods that operate on the data, promoting data abstraction and encapsulation. Then you have something called functional programming. Right. Functional programming. So functional programming in languages like Haskell or Scala, it focuses on immutability and functions as first-class citizens. So data types are often algebraic, meaning they are defined by combining other types like tuples, lists, options, and more to express complex data relationships. Then you have scripting languages. Scripting languages is like it is a huge spelling mistake. Right. So languages like Python or JavaScript are dynamically typed, meaning that variables don't have a fixed data type. The type is determined at runtime, allowing for more flexibility but requiring careful handling to avoid type-related errors in data types, right? So then we have special data types. Special data types. Nullable types. Some languages have special types to handle null or undefined values. In C#, for instance, nullable integer can represent all values of their underlying type plus an additional null value. Right. Helping to manage missing or optional data. Then you have something called tuples. Tuples are ordered collection of elements which can be of different types. They are immutable and can hold a fixed number of items. Tuples are useful when you need to return multiple values from a function without creating a custom data structure. Then you have variant and union types. So in some languages what happens is, some languages like C++ or Rust or Union, the allow union types allow a variable to store values of different data types at different times. This is particularly useful for memory efficient storage, but it requires careful management to avoid some errors. Then you have enum types. Enums allow you to, we have already discussed about this, but these are special data types, so I'm gonna remind you again what they do. They allow you to define a variable that can have one of a limited set of possible values, typically representing different states or unions. So they improve code readability and reduce the risk of invalid values, right? With this, most of the data types are finished, right? So some best practices with data types, which is very necessary in coding, building software applications, is choose the smallest suitable type. Select the data type that most closely matches the requirements of your data. For example, use int for whole numbers, float for numbers with fractions, but avoid using larger types like long or double unless and until it is necessary or deemed necessary. Be mindful of precision or range. Understand the range and precision limits of your data types, especially when dealing with floating point numbers, as rounding errors can occur with float or double, right? Avoid unnecessary casting. While casting is sometimes necessary, excessive casting can lead to bugs or unintended behavior. Always check if implicit conversion is possible before opting for explicit casting, right? So use composite types when needed. Utilize composite data types like array structures and classes to represent more complex data effectively. They help in organizing related data, related data together, and can simplify the design of your program. Leverage type safety. Take advantage of the type safety checking mechanisms of your programming language to catch errors at compile time. This reduces the likelihood of runtime errors and improves the readability of your code. Document type usage. Clearly document the purpose of each data type in your code, especially when working in a team or with complex data structures. This improves code readability and maintainability, right? So real world applications of data types. There are some real world applications of data types like databases. In databases, data types are crucial for defining the structure of tables and ensuring data integrity. For instance, SQL databases use data types like int, varchar, date, etc. to define columns in a table. So you have scientific computing. High precision data types like double, long, double are often used in scientific computing for accurate calculations. Complex numbers and custom numeric types are also used in specific domains like physics or engineering. Then you have financial applications. Decimal or fixed point data types are used in financial applications to avoid rounding errors that occur with floating point arithmetic, ensuring accuracy in financial calculations. Then you have network programming. In network programming, understanding data types is essential for serialization and deserialization of data, right? Ensuring that data sent over a network is correctly interpreted by the receiving system. So then you have embedded systems. In embedded systems where memory and processing power are limited, choosing the right data types, unit 8 or integer 16, is critical for optimizing performance and minimizing the overall resource usage, right? So overall, data types are fundamental concepts in programming, influencing how data is stored, manipulated, and interpreted within a program. By understanding the various types available, primitive and composite, as well as how they interact within different programming environments, You can write more efficient, reliable, and maintainable code. Whether you are working on simple applications, or complex systems, the choice of data types is a crucial aspect of your programming strategy, impacting everything from performance to code clarity and so on. So always remember to use the correct data type and to you know always try to build good structures of data types, right? Use them wisely, use them nicely, right? Do not mess it up.